We are live, so hopefully
Excellent.
you can all see the title slide. So this is the 27th Civo Online Meetup, and I'm really proud to welcome Flynn from Buoyant to talk service mesh and ingress controllers and bringing the outside world in. I believe that is the title of your
Yep.
presentation. Before we really start, I want to just highlight we are doing an event on February 20th and 21st in Austin, Texas. If you are able to get to Texas, or want to join Civo and a whole lot of other companies at an event talking all about cloud and modern computing and GitOps and WASM and DevOps, Kubernetes, that sort of thing, there is a registration QR code on your screen now. And if you use the 50% off code Civo webinar, all in caps, you will get a ticket for half price, which is, I believe it's like $200 for a 2-day event, which is not
That's
bad.
pretty
So
good.
if you can make it down to Austin, we would love to see you. And like I said earlier, just before as we got started, there is a chat, the webinar chat, and the Q&A function. Please use those for any questions that you may have throughout the session. I will then, in case Flynn misses any of those during his presentation, I will flag those up and we'll make sure that we get everything answered. So, like I said, I am joined today by Flynn, who is a technology evangelist at Buoyant, and Buoyant are the makers of the Linkerd product. So basically, we are going to do these introductions. I'm going to hand over to Flynn to do his magic. We're going to do Q&A that we didn't get to during the session itself, and I know we've already had some questions coming in. And yeah, that's it. So I'm going to hand over to
Excellent.
you and basically let you take it away from here, Flynn.
All right. So is that now visible?
It is.
Excellent. So this is a bit of history here. This is a thing that I last talked about using a presentation very similar to this one, but I realized it was about a year ago. So I've gone through and updated some things, and I just want to set the stage for those of you who have watched me demo things before. Um, we will be praying a bit harder to the demo gods because there's a higher chance than usual that this whole thing just completely blows up in my face, and I guess we'll see what happens, right? Um, I would also like to point out that we do have Linkerd certification courses now. You can go to learn.buoyant.io or scan the QR code to go to those. Uh, we've gotten nice reviews on that one. I would love to hear more feedback about it and hear what people think of it. And we also have the Zero Trust Reference Architecture ebook available for download now. Please go and download it. It was a lot of work putting it together, and we would love to hear people read it. And I have absolutely no vested interest in that at all because I didn't do any work on this book. I also have a lovely bridge to sell you. So, with that out of the way, the agenda for this chunk that I'm doing, we're going to talk about the ingress problem. We're going to talk about how you solve the ingress problem. We're going to talk about how meshes work with ingress controllers in general, although obviously I'm going to pitch that kind of heavily towards Linkerd. And then we will do a demo, which is entirely using Linkerd. And if you would like to follow along, that is a thing you can do. You will need a Kubernetes cluster. Things will work out better if it's a Kubernetes cluster that supports load balancers. It's a little bit trickier to get this working on Minikube, for example. I will be using a K3D cluster to go along with this. You will need the CLIs kubectl, Linkerd, bat, and Helm. And if you go to the source directory listed on the screen there, and if we can get that link pasted into the chat, that would be lovely as well. But
Yep,
if you
I'll
go
do.
there, then there's a bunch of scripting. If you look at readme.md, then it will go through and there's code in there to check everything and make sure you have everything you need. So with that said, let's talk about the ingress problem. The ingress problem is interesting because it's kind of the first thing that you end up having to deal with when you're doing things in the cloud native world. You've got your cluster, you have some workloads in your cluster. How do you let people use them who are outside? bearing in mind that this is a thing that clusters are designed to prevent on their own. One of the major purposes of a cluster is to isolate the things inside the cluster from the outside world. The way we deal with this problem is we stick a particular piece of software in the middle, right at the edge of the cluster, that can listen to the outside world and then communicate with the things inside the cluster. We call that an ingress controller. If you look at the nature of the ingress controller, given where it sits, since it's right there at the edge and everything must go through it, it's an ideal place to put control as well as allowing access. So it gets to decide which traffic comes in. It's not just going to let everything through blindly. This means that if you look at ingress controllers and service meshes, there's a lot of overlap in terms of what they provide. They can all provide security and reliability and observability, all of which are very important. A good concrete example of this one is gRPC load balancing, where Kubernetes just out of the box is very, very bad with load balancing gRPC because gRPC tends to stream multiple requests down one connection, and Kubernetes by default wants to load balance connections, not requests. So both an ingress controller or a service mesh could do a better job and load balance by request. The big difference is that, whoops, sorry, I'm getting ahead of myself. I wanted to point out that if you're doing advanced things like this beyond just letting connections through, then you will hear people talk about API gateways instead of ingress controllers. Same thing, just a question of which one can do more. But the major difference here is that the ingress controller can only influence things right on the edge of the cluster, whereas the service mesh can influence things everywhere. And this is just because of where they're positioned. The ingress controller lives on the edge of the cluster, so it can't affect things deep in the call graph. The service mesh is spread throughout, so it can affect things deep in the call graph. Which tool you use to provide a given bit of functionality often comes down to where in the cluster you need to provide it. All right. And yes, you will generally want both a service mesh and an ingress controller if you're doing things in the real world because of that dichotomy. Okay, an important note. Kubernetes also has a resource called ingress. And when we talk about the ingress problem, we are not necessarily talking about the ingress resource. The ingress resource is kind of old. It's kind of limited. It is, in fact, in the process of hopefully being replaced by Gateway API. I say hopefully just in the sense that Gateway API is fairly new and still being adopted and all of that. But so far, so good. It's looking pretty promising, and I'm hopeful. When we talk about ingress as a concept, we are talking about this function of carefully providing a controlled way for traffic outside the cluster to make its way to services inside the cluster. And like I said before, this does not necessarily mean that you're using the ingress resource. So if we look at how service meshes work with ingress controllers, I'm going to talk first about how Linkerd in particular works with ingress controllers, because there's a particular nuance here that's important. From Linkerd's point of view, the ingress controller is just a meshed workload. That's all there is to it. Linkerd is 100% agnostic to which ingress controller you're using, as long as you can put a proxy next to it and bring it into the mesh. This makes things a bit interesting if you're trying to do things like use a GCE cloud load balancer, for example, or a GKE cloud load balancer, things like that, where you can't put a proxy next to it. This is also a bit of a departure from the way some of the other meshes work, where Istio, for example, builds in the Istio gateway as an ingress controller, and you can make other ingress controllers work with it, but you have to jump through some hoops. So depending on which mesh you are using, you may have an ingress controller that's baked in, or you may not. Linkerd does not, and we particularly go to a little bit of effort to try to allow you to use whichever one you want, which in fact you will see in the demo today. Okay, some gotchas with ingress controllers, and here I'm going to talk about some specifics with Linkerd, although again, the concepts apply elsewhere. The first one is that you often will have a way to explicitly tell the service mesh to skip incoming traffic coming to your ingress controller, to not try to route that through the mesh. This is important, for example, with Linkerd, where if you don't skip the port for incoming traffic, then your other workloads, in particular the ingress controller, instead of seeing the IP that the traffic is actually coming from, it will see only the IP of the Linkerd sidecar, which is probably not ideal if you want to do things like limit traffic to only particular IP address ranges. It's, I suppose, technically possible to do goofy things with the sockets inside Linkerd to recover it, but that turns out to introduce lots of fascinating questions with Linux and all that, so we don't do it. And instead, what we say is just skip the incoming traffic. Skipping the incoming traffic is always safe. The ingress controller, any ingress controller must be designed to sit out there right on the edge of the internet. And so it is always safe not to have another layer in front of your ingress controller, because that's what your ingress controller is designed to do. Conversely, if you're using an ingress controller and you're not sure if you trust it, pick a different ingress controller. So that's one thing that's kind of important about this. The way you actually do this within Linkerd is with an annotation on the ingress controller pods. Please note you must annotate the pod, not the deployment, which is an annoying thing. It's also important to note you want to skip the target port, not the service port. So if we have this service here, then you need to skip 8080, not port 80. And basically, this is because by the time the traffic goes through the layers of Kubernetes networking and actually hits the ingress controller or the service mesh, then you're not going to see the source port anymore. It will already have been rewritten to the target port. This is also probably a good point to remind people there are ways you can toss questions in the chat or in the Q&A box if you want them answered. I'm going a little bit quickly because I want to make sure that we don't run out of time, and that means I'm possibly at risk of confusing people.
Yeah, if anybody is
Yeah,
confused, please, do
speak up.
yeah, exactly. Speak up figuratively in the chat, and we will. Flynn has said he's gracious enough to field questions on the fly. So, please do ask.
Yeah. Otherwise, we'll just assume that we're doing it perfectly and you understand everything, and not that you're sitting there going, I don't understand. Although, I mean, they're probably equally likely, right? Another thing that happens when you start talking about service meshes is you get this question of, if you are talking, suppose you set up your ingress controller to say a particular chunk of traffic comes in, it needs to go to service foo. Do you expect to see requests directed to the cluster IP address associated with the service foo, or do you expect that traffic to be directed straight to one of the endpoints of service foo, to one of the pods that's actually providing the functionality of it? This turns out to be a big bit of division within the service mesh community. Linkerd expects to see connections go to the cluster IP for the service. So the point of this is that Linkerd expects, well, sorry, let me back up. The point of this is that if you speak to the cluster IP of a service, then it is always possible to take the cluster IP and figure out which service you were trying to talk to, from which you can figure out its endpoints, from which Linkerd or any other mesh can go through and do fancy load balancing things. If you are instead speaking directly to an endpoint, it is not in general possible to figure out which service you were talking to, because you can have multiple services that both select the same set of pods, or that all select the same sort of pods. So this is, this is a thing that you have to decide. Sometimes that business where going to an endpoint, or sometimes you want to go straight to an endpoint and you want to bypass the service mesh's load balancing. A good example of this is if you're using Emissary with its endpoint resolver, you are explicitly saying, hey, I'm doing things in my ingress controller where I care a great deal about which of the backend pods I've connected to. You're doing something where you need sticky sessions, for example. And in that case, you will want to bypass the load balancing that the service mesh does. In other cases, that is not what you want, and you're using an ingress controller that just doesn't know how to do that. For example, the Istio gateway really, really wants to speak directly to an endpoint all the time. So if you were to use a gateway like that with Linkerd, you would need to annotate your ingress with the ingress mode, linkerd.io/inject:/ingress rather than :enabled. And that will tell everything that Linkerd at that point will expect a header that has the name of the service for each request that comes in, and then Linkerd can use that to figure out what you were trying to do so it can do load balancing. Kai
Can I ask
unmuted,
a
which makes me think there's a question.
Yes, there is. There is indeed one from Lionel, who says, "I'm a newbie with Linkerd. Would this replace the NGINX ingress controller, and how does it support any multimedia streaming traffic, WebRTC, and similar?" And I mean,
So
yeah, go
go
ahead.
ahead. So there are two very different questions in that.
Yeah,
Um, Linkerd at present will not replace an ingress controller full stop because Linkerd does not provide the ingress functionality right now. So instead, you would run, I'm actually going to show running NGINX with Linkerd. It works great. And so you could use NGINX or any other ingress controller of your choice on top of Linkerd. Almost any other, ingress controller of your choice. Supporting multimedia streaming traffic, you have two options. The first one is a lot of the multimedia streaming things, if you look at them, are actually baked on top of HTTP connections, which Linkerd understands quite well, and you don't have to do anything special for. If you are using something that you really must do something special for, you have the option of using raw TCP connections. You just tell Linkerd, hey, traffic to this port should be considered opaque or should be skipped entirely. The thing that is sort of buried in that question, although not explicitly stated, is protocols like SIP, which are UDP. And Linkerd doesn't really do UDP right now, unfortunately. I suspect that that will be changing at some point in the future, but that is a limitation that we have right now. I also see a second question here where it's setup and pure BGP ingress controller. Let's come back to that question later. But while we come back to that, Petru, I would like to, if you could supply a little bit more about your use case while we're going on with some other stuff, I would appreciate that because I feel like you could mean several different things with that, and I'd like to make sure we try to answer the correct one. Okay,
thanks.
we were talking about ingress mode. You do not really want to use ingress mode with Linkerd if you don't have to, and the reason is it requires your ingress to do some more work, tacking the special header in to say, this is what I was trying to talk to. If you can avoid it and just have the ingress controller speak directly to the service, then that tends to be better. There's less parsing of HTTP headers and things like that going on. Parsing, as we all know, is the root of all evil, and you want to avoid it wherever you can. All right, I might be exaggerating slightly. Okay, I believe it is demo time. The demo is we're going to show using actually Emissary first and then NGINX and then Envoy Gateway in a cluster that I've already set up. So we're just going to be swapping between ingress controllers to see interesting things happen. Underneath it all, we shall have Linkerd running, handling the mesh part of the world. We'll be looking a little bit at Linkerd observability while we do this one. But mostly this is about demonstrating the way that we can go and flip ingress controllers whenever we want to. Let's just go ahead and get to it and see what happens. All right. So, like I just said, we're going to look at Emissary-ingress, we're going to look at NGINX, we're going to look at Envoy Gateway. I have already set up the cluster because setting up the cluster and installing Linkerd and installing Emojivoto, which is our stupid demo app that we're using this time around. Sorry, stupid in the sense of it doesn't do very much, not stupid in the sense of I don't like it. I like it
It's
fine.
actually very, very nice.
Yeah. It's it's kind of not my favorite demo at this point, but that has more to do with the fact that um, for example, if I'm trying to show off some more of things that happen under the hood, then I feel like there are better demos for showing some of this stuff. But yeah, Emojivoto is fine, especially for what we're doing here. So um, I pointed earlier, and it's in the chat, the source code for this demo. If you go there, this is all in the readme.md file. It has both the text and the executable code, and you'll be able to follow along. So we have a cluster. Linkerd is already installed. Emojivoto is already installed. off we go. First thing we're going to do is we're going to start with Emissary-ingress. I'm going to use Helm to install Emissary. So I shall add my Helm repo and update Helm, despite the fact that I've done this 47 times in the last 12 hours. The first thing we have to do with Emissary is install its CRDs. The weird thing about Emissary is that installing the CRDs also brings in a conversion webhook. And so we will now wait for the conversion webhook to be ready. This would be a lovely time, Kai, if you have any questions while we wait for
Uh,
the
I
conversion
I'm going
webhook
to
to start.
preempt the question that I'm also going to put into the chat, which is, oh, how are you doing the smooth scrolling demo terminal thing? And the app is Demosh, isn't it?
The app is called Demosh. Thank
Yeah.
you for asking about Demosh. I think, yeah, there we go. That's the thing that I'm using for all this. I'm quite fond of it. I also wrote it, so I would hope I'm quite fond of it. And yeah. All right. We've gotten the conversion webhook going. That's great. And the next thing we're going to do is we will create Emissary's namespace. We are creating this ahead of time so that we can annotate the whole namespace with the Linkerd inject enabled annotation to tell Linkerd absolutely any pod that shows up in this namespace, go ahead and inject it into the service mesh. There are other ways we can do this, but this is one of the simplest ways we can do this, which is why I'm doing it this way. Now we'll use Helm to install Emissary itself. The only variable that I'm setting here is I'm explicitly setting the replica count to 1. Don't do this in production. I'm only doing it because this way I get to have some of the least things going on. Great. That's just lovely. You remember when I said that the chances that the world would fail were a little higher than normal?
Yep.
Yeah, well, actually, it looks like we might be okay as I look a little bit behind the scenes. So I'm just going to continue on.
So is this one
And
of
if
those
this,
eventually consistent type of things?
I'm hoping that it's one of those eventually consistent kinds of things. Yes,
Okay, fingers
it's
crossed.
possible. Hey, there we go. Okay.
Nice.
So at least we hope it's nice. Maybe nothing is working under the hood, but it still came. We'll find out in a minute now, won't we? Right? This is how you know we're doing it live, folks. Um, so we're going to quickly configure Emissary-ingress. Emissary is a little bit interesting in that it has its own configuration language that's used for nothing else. And the first thing that we have to do to configure Emissary is set up listeners and hosts. Here we're doing, right, so if you see traffic on port 8443, assume it's HTTPS. If you see traffic on 8080, assume that it is HTTP. And then the other stuff is saying, just go ahead and deal with all of the hosts that you find, host being a resource. And this is all, documented with Emissary, so I'm not going to go too far into it. This host CRD is basically saying, yeah, so absolutely any host name. And oh, by the way, HTTP is okay. Don't try to redirect it to HTTPS. I'm doing things that way because I do not want to get mired with certificates during this particular demo. So after we have the listeners and hosts, we will also be applying a mapping, which says any traffic at all coming to the hostname emoji.127.0.0.slip.io should be directed to the web service in the Emojivoto namespace. If you are not familiar with slip.io, it's kind of slick. It's a DNS resolver where if it sees anything that looks like an IP address in a name, it will resolve to that IP address. So it's a great way to not have to set up your own DNS, but still be able to do name-based routing, which I think is pretty cool. All right. So we'll apply the hosts and the listeners. Um, that's not so great. You remember I was worried about this? This is what I was worried about.
This specific handshake.
Yeah. Okay. Well, you know what? I'm going to try this again. All right. Let's see what happens, shall we? So I believe you could see a web browser now.
We can indeed.
Excellent. Now I just have to find it. All right, here we go. This is making me sad.
Oh
All
no.
right, so here's what we're gonna do.
If anybody in the chat has any questions, this is the time to paste them in, so that I can ask them from Flynn once he's recovered from this
So,
thing.
yeah, so here's a fun question. Do I just go on or do I actually try to fix this?
I
I
mean,
think I'll
I'd
try to
love
fix
to
it.
see, I'd love to see you fixing it.
So what I'm going to do here is I am going to restart the deployments in Emissary system because that's where APIX lives, and APIX is the thing that was breaking. So we shall just wait for it to go.
For what
And
it's
then
worth,
after I
we
do
are
that,
looking at a browser with the site can't provide a secure connection.
how about that?
That's perfect. Thank you.
Sorry about that.
No, no, no. I mean, it happens to me every time. So,
Yeah. But thank you for the thanks for the catch. So what I've just done there is I've restarted one chunk of Emissary, and now I'm going to restart the rest of it. Except it would help if I type restart instead of status the first time, you think? The really ironic bit of this is that I'm also the original author of Emissary. So this is me looking over and going, my own product is breaking under me. I do not appreciate it. But like I said, hey, this is how you know we're doing it live.
yeah,
Um,
exactly.
yeah, this is one of
So,
the fun things with the Cloud Native live streams, if you've ever seen those,
yeah,
where they start with, we will build things, we will break things. And it's like, yeah, we're gonna break some stuff, all right.
yeah. And if there's anything that any kind of cloud engineer knows is that stuff breaks inadvertently, and then you just have to find
Hmm.
clever ways of going, oh wait, why did that break? Oh, you're still getting the handshake error.
Which is a little fascinating, honestly. I'm not gonna lie. I am suspecting that this is an issue with CPU actually in my machine. So other reasons why you shouldn't be doing this while, well, other reasons why running K3D for your demos can be a little bit difficult.
Uh, I would
Ah,
be remiss
okay.
if I were to not plug a certain cloud provider that provides extremely fast cluster
Why, really?
launches.
Do you, wait, you say you know of a cloud provider that's really good at this? That's
Yeah, I'd say
amazing.
that.
Who is that?
Well, see, they're called Civo, and
Oh,
they
really?
run multiple regions around the world, and you can choose between running a cluster based on K3s or a
Hmm.
cluster running Talos.
I confess I did not actually know about the clusters running Talos.
Yeah,
Um,
that's newer than the K3s stuff, but yeah, but you can choose that for any of your clusters, except for if you're running clusters with GPUs attached, then they have to be Talos.
mm. Oh, okay, that's interesting. Yeah. I have used Civo clusters on a great many occasions, actually, and I have generally been quite fond of them. Um, there was a point, actually, where I was having trouble that I realized was because I was doing the wrong thing with the Civo command line. And so I felt very bad and had to go back to your CTO and apologize for all the bad things I'd said to him.
Well, I mean, to be honest, if something isn't intuitive from the command line, and if the errors aren't, what that kind of falls on my desk to triage. So, you know, so
No,
anybody
it's
watching,
it's
if you are using the Civo command line and it's not giving you what you would expect, fire over an issue and tag me on GitHub. We'll have a look.
so um I did figure out what was burning up the CPU on my machine and got rid of it. But I think that what I'm going to do right now is I'm going to continue with the other controllers, and then I am going to smite. Well, the next step is actually to smite emissary. And I think we'll come back to that afterwards and
Works
see
for
if it's
me.
happier being completely reinstalled. This is a fascinating failure. This is not something I've seen a lot.
So you were
So
expecting a failure, just not here.
I was not actually expecting a failure in this one, because it worked just fine when I ran through it this morning. All right, so let's do this. We're going to skip that. We're going to go ahead and clean up emissary. And we're doing this in kind of a rude way by just deleting the service and then just deleting the namespace. Josh van der Linden says the demo gods are displeased. They are clearly very displeased, enough so that I'm kind of afraid to see what's going to happen next. But so the trick that I just did there was delete the service so that I know that we don't have anything that's going to compete with the same port I want to use for NGINX's load balancer service. And then I just told it to delete emissary's namespace entirely. Um, I did not, I then hit Control C rather than waiting for it to finish deleting the namespace so we can go on. I will use Helm to install NGINX as well. And let's go ahead. I'm going to use exactly the same trick, though, of I'm going to install NGINX's namespace. I'm going to annotate it for Linkerd injection, and then I'm going to install NGINX in that namespace. So we'll do that. Okay. And while I am doing that, I am cleaning up some CRDs for emissary in the background for next time. All right. NGINX, part of the reason that I picked these three Ingress controllers is that they all use different configuration mechanisms. NGINX is actually configured by the old Ingress resource that I was kind of bad-mouthing earlier. In this particular case, the Ingress resource does fine for what we need it to do. All we need it to do is take, again, traffic to the emoji.127.0.0.1 slip.io host, any path starting with a slash, which is to say any path, take it to the web service service. An important thing is that we have to put the Ingress in the Emojivoto namespace because we need to be talking to a service in the Emojivoto namespace. So let's try this again, shall we? Back to the browser. All right. There's something else going on.
At least it's not an SSL thing this time.
Yeah, seems like it can't be, can it?
I mean, is it possible that slip.io is down?
It seems unlikely, but let's find out, shall we? Nope, it is not down. All
Darn.
right. We're going to back up and blow the cluster away and restart. The real question here is, how brave am I? Am I brave enough just to start over with a Civo cluster? What do you think? Should we try that?
I think you should.
Let's give it a shot. Hang on a moment whilst I get this done. All right. So now we're back. Y'all can see my screen, right?
Yes, we can see your terminal.
Okay. This is gonna be kind of fun. So I've just gotten rid of my clearly malfunctioning cluster. And I think that's the way I did this. So this is a script that I have that uses the Civo command line under the hood because I never quite remember what exactly I want to do. So this is me running my little script to say, just get me a new Civo cluster called Ingress. And hopefully that will work out correctly. While that is going on,
I have a question from the
shoot.
audience. Um,
Yeah. Other
um,
than the demo gods being displeased?
yeah. So I mean, this was one of the ones that came in earlier, but it's around upgrading. We've had some trouble with ingress/mesh when upgrading K8 versions in the past. How do you do this correctly?
Um, I'm sorry, was that question around? I'm terribly sorry. I was
You know,
typing something while asking that.
yeah,
Are they
fair.
asking, is the question about upgrading Kubernetes or is the question about upgrading the Ingress controller?
So I'm assuming it's when upgrading Kubernetes and sort of ingress and mesh issues
Okay.
happening around the upgrade process.
So, the way I personally deal with Kubernetes upgrades is I get a new cluster with the version I want and treat the cluster itself as a fungible object. I don't actually like trying to upgrade Kubernetes in situ. I think it's considerably more dangerous than it needs to be.
So
Um,
basically treating a cluster like you treat pods.
yeah. And
Fair.
I recognize that that is sometimes a little bit difficult. Um, but yeah, it actually has a bunch of really nice things because it means that you don't have to go through and spend a bunch of time worrying about, okay, how do I do this upgrade exactly? You can instead spin up the new cluster, install the stuff you want on it. You have a beautiful test bed for getting things to work correctly, and then you eventually end up swinging a DNS record to do the migration. Um, if you want to get really fancy, you can actually canary entire clusters, which is a really, really cool thing to see. So that's how I personally like to deal with it. It's the idea of getting to a place where you can treat the entire cluster as cattle instead of pets is a real win in a lot of ways. It also has the advantage that if you want to switch cloud providers in the process, you already know how to do that. And that's,
Because you've set up the whole thing. Yeah.
yeah, because I mean, that's a huge win in a lot of ways. Modern service meshes also do a nice job of being able to allow you to do multi-cluster setups as well. So you can have some services in the new cluster and you can actually move traffic between them. There's a bunch of really cool stuff you can do. This was actually the topic of the most recent Kube crash where we played with some of these very things. That's at kubecrash.io.
Mhm.
All right. Okay. Everybody cross your fingers. This will be fun for some value of fun, I'm sure.
I mean, it looks like the cluster's responding well at least so
Yeah,
far.
yeah. You will have noticed while we were talking that I was doing kubectl get ns a few times, and
Yeah.
the first couple of times I got an error from the metric server. And this is a thing that I have seen a lot where I don't really know why this happens, but sometimes the Kubernetes metric server just takes forever and a day to come up. Um,
Which
honestly,
is
when I'm
interesting considering how fundamental it is to so many
to,
sort of
to freaking
things,
everything,
right?
yeah,
Yeah.
yeah. I'm not going to lie, when I'm setting up K3D clusters, I tend to disable the metric service for exactly that reason. Just like, okay, I don't want to wait for it.
Yeah.
And one of these days, hopefully soon, I will have bandwidth to figure out what's really going on. Why is this taking a while? Because it really shouldn't be. So what I did here was I installed Linkerd CRDs, then I installed the Linkerd control plane, and now I am running the Linkerd check command, which is telling me that everything is okay. This business, um, a bit of a look behind the curtain here. I happen to be running Linkerd's Edge 24.1.3 release because I needed it not too long ago for a mesh expansion demo, and I haven't bothered upgrading since then. Since then, a new Edge has come out, and so
Hmm.
now these yellow things are Linkerd telling me, hey, dude, you're a little bit behind the curve. Get with the program. It's okay. We don't actually need anything new here. This bit is because I am also using the Linkerd Enterprise CLI. And it's telling me, hey, dude, you haven't hooked yourself up to all the cool enterprise monitoring things, which is true. I have not, because I don't need to for this demo. So moving on. You, of course, if you're trying this, you should hook up all the enterprise stuff because it's exceptionally cool. And I think that's actually No, sorry, the previous Service Mesh Academy that we did in January was about Buoyant Enterprise Linkerd, and the next one will be about mesh expansion. So lots of opportunities to see cool things.
And the Service Mesh Academy link is in the chat.
Right. That's buoyant.io/SMA. That's we do Service Mesh Academy every month. And yeah, it's you can learn a bunch of cool things. All right, let's install Emojiboto. Thankfully, Emojiboto is quick to install. And then we're going to try this again. If this doesn't work, I am not going to lie. If this does not work, I am just going to throw up my hands in despair and declare that the demo gods have it in for me and that y'all should try it on your own and hopefully it'll work better. But I'm fingers crossed. Yeah. I know the Kubernetes configuration file is the wrong permissions. I don't care. Carry on. All right.
So this is the emissary now.
Right. But we're using a Civo cluster. I suppose it's also worth pointing out that since my K3D cluster was being so impolite to us, everyone is getting a fairly interesting demo of the way Linkerd really doesn't care what kind of cluster it's running on.
Yep.
And clearly Civo provides a cluster that is, kind of just going to work and is a good thing. Or
Plus
let's
it,
see.
rolled out in what was that, a minute and a half? You were just able to answer a little bit about not upgrading clusters in place, but rather building a
Yeah.
second one and
Oh,
then moving
look,
over.
my cluster is sick. I shall throw it away and get a new one.
Yeah.
Big fan of this particular model. I don't believe I spun up a Talos cluster. I believe I spun up a K3S cluster.
Yes, by
Because
default,
I,
unless you
yeah,
specify where we keep them to K3S. The plan is eventually to potentially make Talos the default, but right now it only defaults to that if you're doing funky things with GPUs.
gotcha. I did not do anything funky with GPUs, so I assume that we are getting K3S.
Yes, that is correct.
Alrighty. So I can see behind the scenes that Emissary is doing its thing and coming up. There we go. So far, so good. Oh, that looks so much better. Okay, now I am going to have to cheat a bit because this is no longer at 127.0.0.1, right?
Yeah, you're gonna have to get the
It is, in fact, at 212.2.247.103. So allow me to edit my mapping here. With Emissary, we get to put the mapping in the default namespace because Emissary doesn't really care. And with NGINX, we have to do things a little bit differently, but that's okay. All right. Now I come back over to my browser and I'm gonna fix this stuff up.
swap the dots for dashes.
Yeah,
Oh
I know it
no.
can't. Well, yeah, but I know it can't do that. I don't want it to do that. Hey, there we go.
Boom.
I was getting really concerned about the demo gods this time around. All right. Whew. Now, we did actually see it serving some traffic. Next thing I'm going to do is I'm going to crank up the Linkerd Viz dashboard, which appears at this particular, this particular place. So if I come back to my web browser, I have cheated massively. And if I come over to the Emissary-ingress bit, then you can see that our Emissary-ingress deployment is in fact talking to the web deployment over here. We can scroll down a bit and actually let me reload this a few times so that we get some traffic happening. If I come back over here, you can see Emissary talking to deploy web, which is kind of nice. You can also see this, unmeshed traffic from 10.42.1.1. That is actually the cluster doing health checks and things like that. So, okay, this is working much better than it was before. I'm pleased by this. The demo gods have started smiling at least a little bit upon us. Okay. I think we have time to go ahead and try NGINX as well. Let's see what happens now. Thank you. And Kai confirms, yes, this is a K3S cluster. Always good to know. Okay, so backing up, since I just was blazing through all this stuff the second time around. For NGINX again, we've created the NGINX namespace. We're going to annotate that with the Linkerd injection so that when we install NGINX, it should just get automatically injected with Linkerd. Injecting here is the term we use at Linkerd for the Linkerd itself is adding the Linkerd proxy to all the new NGINX pods. And let's go ahead and get that up. We're going to have to edit this as well, which is okay. That went into the Mojivoto namespace. That didn't work.
So what you need here is the IP address for the host. Yeah.
Right. I just copied that out of my browser, but of course that copied as a URL. And the rest of this should be fine. Oh, it's not going to be at 103 anymore. It's going to be at 107. How very polite of the. This is one thing I actually do really like about the Ingress resource is it tells us the IP address of its load balancer right there.
Right, yeah, because this spun up a load balancer as you installed
Right.
it. Yes.
Yeah, and that's a very nice thing about the Ingress resource. It's not, I mean, the Ingress resource is not the only one that does this, but it's still a nice thing. The mapping resource for Emissary doesn't do that for historical reasons. Okay, so now we've got that done. And if I check this out in the web browser, I did that and then I cleverly didn't save the IP address. That was kind of
It's
dumb.
107, isn't it?
Well, I just cheated by uh, I did a kube control get ingress and it actually, you know what? Let's just show that, shall we? And it hopefully has the host right here in the status for ingress.
You're still showing the browser. Sorry.
Like I
Yep,
said, it hopefully has the host right here in the ingress output.
that's
This is a
cool.
thing, this is a thing where one of the tricks as we're doing more and more stuff with CRDs is that CRDs can't really, they don't have that sort of nice pretty printing yet. And that's a thing that a lot of discussion is happening about. So there we go. NGINX is working. Props again to Civo for giving us a working cluster. And we can go back to the Linkerd Viz dashboard again. Those errors are because this is trying to look at the emissary namespace, which no longer exists. Instead, I can come and look at the NGINX namespace. And if I then come back over here and look at the NGINX ingress controller, then we can see again, it is now talking to deploy web. And we can see it going through and talking, and all is well in the world. Which is always a really nice thing, actually. Okay. We're going to clean up NGINX the same way we did with Emissary, where we are just going to delete the load balancer service and then summarily delete the entire namespace. And now we're going to move on to Envoy Gateway. Envoy Gateway is extremely new. You can see that we're installing version 0.6.0. Envoy Gateway is aimed at using Gateway API to manage the Envoy proxy in Kubernetes. So This is actually, there is a way to install this using Helm, but I'm just doing it with kubectl apply right now because it's a little bit simpler. While we're waiting for this to come up, one of the really interesting things about Gateway API is that where with Emissary and NGINX, we installed the controller. What's happening with Envoy Gateway and other Gateway API implementations is that you kind of install this meta thing where you then create a gateway resource, and the gateway resource is the thing that causes your controller, your English controller, to appear. And this is a little bit weird at first. So what we've done here is we're going to go and install Envoy Gateway. It has put that thing that is watching for gateways into a namespace called Envoy Gateway System. When we create a gateway resource, it will spin up an entirely different deployment. So we will go and annotate the entire Envoy Gateway system with the enabled bit.
There's
I
just
am
been
not, I'm not going to restart the currently running Envoy Gateway pod, so it is not going to be in Linkerd, which is okay because it's basically, cluster infrastructure. Is the meta thing dissimilar from an operator? It actually is an operator. It's an operator that watches for the creation, deletion, and or updates to gateway CRDs.
Thank you for spotting that question.
Yes. I take it back. We will restart the running Envoy Gateway controller. And this is my expression when I'm looking at this going, I don't really know why I decided to do that because it shouldn't be necessary. But whatever, we'll do it. We'll trust me from
We'll
a
be
year
extra
ago thinking
safe.
this was a good thing. Yeah, why not? Honestly, we're going to trust me from a year ago, and then me today is going to go and look back at this and go, I really don't think we need this, and I'm going to test it without it.
I
Okay.
mean, is it possible that it was necessary and no longer is, because of versions?
So I'm actually involved with the Envoy Gateway project and with Gamma, the Gamma initiative within Gateway API. And I can't think of a reason why it should be necessary because the controller that we just meshed there, you basically never talk to it. All it does is just sit there and watch for gateway resources to appear.
And then
So
pops
it
out the ingress
and then it
accordingly.
pops out the Ingress controller itself. So the Ingress controller is the one that you care about being in the mesh, and the gateway can, this is terminology here is really weird, but the thing that is currently running, nobody talks to over the network, so you shouldn't really need to mesh it. The thing that it creates that handles traffic very much needs to be in the mesh. So what we're going to do here is we are going to create a gateway class which says, hey, if you see gateways with the name EG, and that stands for Envoy Gateway, not for example, then you want that to be something picked up by the Envoy proxy. The gateway.envoyproxy.io is the kind of the URL for the Envoy Gateway project. This, we're creating a gateway. It will listen for HTTP on port 80. It will accept any route from any namespace, and its gateway class name references this gateway class. So the Envoy gateway controller should pick it up and do the right thing with it. Finally, we shall install an HTTP route. This is a gateway API HTTP route, and these are also gateway API resources. Once again, we're going to have to edit this host name once we're done, but this is basically binding to the EG gateway, which is a member of the EG gateway class, and to any host, a path that has a prefix of / will go to the web service on port 80. And once again, we're doing this in the emoji-builder namespace because that's where web service is. Let's apply that. We are not yet going to do that. First, we are going to edit that HTTP route
To get the correct IP address in.
to get the correct IP address. Oh, this is going to be kind of interesting. What is the correct IP address?
43.
243.43.
Yeah.
I have a funny look on my face because I'm very concerned that what might happen is that I edit this and then it spins up a different,
A different version. Yeah.
yeah. So we might actually have a difficult time showing this off without having a proper DNS setup, but let's find out. This is another thing where since this is an area where it's a little bit weird about Gateway API, since the Gateway API really, really wants to control all of these resources for you so that all you have to think about is, say, the gateway resource. And on the one hand, this could be really useful. On the other hand, it can be a big problem. Um, so first off, let's see, did it do that? It either did not do it or we happened to get exactly the same IP address. So I think we're good to go. If it had changed it, I would have edited the HTTP route again to have a host name of star.slep.io, and then we could have gone on. All right. So let's see what happens, shall we?
So you need to change it there as well.
And I need to make sure that it doesn't update with HTTPS.
Yeah, it's serving traffic.
There's something a little bit strange going on here because you'll notice it's just kind of waiting right now. Oh,
Oh,
somebody,
Josh has just noticed that the IP has changed. Oh yeah, you've got 107 up there. Yeah.
you know what? I
Yeah.
bet you I hit Command R instead of, that was kind of
And
dumb, wasn't it? Well, props to Josh for noticing
exactly.
things
I'm
weren't
glad that we
working.
have eagle-eyed watchers.
Yeah, it's great. You know. All right, so now this is
Yay.
working. Woohoo! And as always, we should be able to use the Linkerd viz dashboard again. Once again, we're getting errors at the bottom because I'm looking at a namespace that doesn't exist, but now I can look at the Envoy Gateway system
And can you open your
namespace.
browser or share your browser window rather than There we go.
In case you haven't noticed, I've clearly gotten a little bit too used to having the demo switch windows for me, huh? Um, so here we can see our Envoy default EG Echo 41 Echo 7 Bravo 31 deployment, talking again to our web deployment over in Emoji Photo. And let me come back over here, generate a little bit more traffic. And here again, we can see these calls to deploy web. Let me show off something kind of fun about Linkerd while we're at it. I can do a tap on this traffic. And if I come back over here, oh, it would help if I actually clicked the start button, huh? Oh, I just realized what's happening. So over in another window that y'all cannot see, I opened another browser window onto my emoji book thing because the moment this tap window loses focus, it turns the tap off. But here I can go through and I can actually take a look at this and I can look at the headers and I can look at the response and the latency and all this stuff. And I can do that in real time for anything that's going on, which is just one of the many wonderful things that a service mesh can do for you. And
And I
with
like the
that,
fact that the actual service itself did not
yeah,
care one iota about what it was being served through, like what
yeah,
the ingress itself was. It was just happily serving through whatever.
yeah. And that's the way, really the way this should work. You should be able to mix and match components in the cloud native ecosystem if everybody is cooperating properly, unlike my K3D cluster from earlier.
But
Uh,
I'm glad that we had a fast cloud provider to replace it
yeah,
with.
it was, it's almost like I was planning to do something where it wasn't working locally, so I had to switch to our friends at Civo and their wonderful cloud provider clusters. So anyway, there you go. 3 separate Ingress controllers working cleanly with Linkerd once we got a nice fast cloud provider cluster going. Thank you to Civo. Here again is the source. If you look at readme.md in there, then you should be able to follow this on your own. Hopefully you'll have better luck with K3D than I did. Uh, like I said, it worked every time I did it before firing up Zoom and having my VS Code thing go completely stark raving mad on me. Um, I don't know how much time we have for questions. I wanted to point out again that next month, or sorry, next 2 weeks, not next month, it's already February. February 15th, we'll be talking about mesh expansion in the Service Mesh Academy. We'll be talking about specifically how you can use Linkerd 2.15 to bring in workloads that are not running in Kubernetes and have them interacting with your Kubernetes workloads via the Service Mesh. And I mentioned Buoyant Enterprise Linkerd earlier. It's pretty cool. You can go there and check it out and get a free trial. It has some really nice stuff baked into it, so I would encourage you to look at that. But otherwise, now is a lovely time to talk about questions if we have any.
Yeah,
And I think
there's a
we shall
couple
go ahead.
that
Yeah,
have
go
come
ahead.
in, and the let's see, which one should I start with? Um, when should I not use a service mesh?
Never.
As in always
It's
use one.
it. I'm obviously being slightly facetious because I'm a bit biased since I work for a company that does service meshes, right?
And
But
that's
one
why
of
I
the
asked this
really,
question.
yeah, one of the really fascinating things, though, um, so by way of background, before I came over to Buoyant, like I said, I'm the original author of Emissary-ingress. So I was living and breathing Ingress controllers, and we tended in that world to say, hey, maybe you don't need a service mesh at the beginning because they're very complicated. And the fact of the matter is, once I came over to Linkerd, I found out that we were wrong, and your service mesh does not actually need to be complicated. And if you start from the idea that it doesn't really need to be complicated, so Linkerd, you literally install it and you get security and observability completely out of the box without configuring anything at all. And at that point, why would you not use it? It's a huge win for very, very little effort. You do have to configure reliability stuff. Not going to lie. We cannot just guess which things can be retried, for example. Um, but yeah, if you pick a lightweight service mesh, there's almost no reason not to use it, even if you're a tiny 4-person startup.
I think that was exactly the point that I would have pointed out is the lightweight argument, is that there
Yeah.
are, and this is going to lead to the next question. Um, but it's I think people are scared of the resource impact of sidecars and whatnots, you know?
Yeah. We see a lot of stuff from people who are saying things like, "Oh, how do I run without sidecars?" And our usual answer is, why don't you just pick a sidecar that doesn't cost you much to run?
Yeah.
Because it and I think one of the other questions that often comes up, so I'll just preempt it, is, oh, well, what about Linkerd versus Istio? And for Istio, in this case, we can substitute Envoy-based service meshes. Envoy is a lovely proxy. It does a lot of awesome things, and it consumes a lot of resource,
Mm.
um, which can be a problem. The Linkerd proxy is not Envoy. It's a purpose-built Rust micro proxy, we call it. And it tends to consume something like 1/10 of the resource that Envoy tends to. So it just isn't as big a deal. Um, One of the really nice things about the sidecar architecture is that since the sidecar lives within your pod, all of the things that you're used to in terms of lifecycle management for pods and all of those things, security boundaries around the pod, they kind of just work when you're using the sidecar architecture. And if you want to go to something that is using a node-based proxy instead of a pod-based proxy, then they introduce some really fascinating operational and security questions.
I mean, you did preempt the next question, so Um, and then I guess
Glad I
there's
got it
just
right.
yeah, you did. Yeah. I guess there's just one more left, which is how to take care of auto scaling of ingress controller slash gateway to handle peak traffic.
That's an interesting one. So anytime you bring up autoscaling, there are multiple different ways you can approach this. And
Going this way, that way. Yeah.
some of it's going to depend on your Ingress controller, the specific one you're using. Um, broadly speaking, broadly speaking, the thing that you would really like to do is ideally scale the data plane. So, scale the things that are actually handling your data independently from the things that are handling configuration of the Ingress controller. Some Ingress controllers permit that. Some of them make it easy. Some of them permit it but don't make it easy, and some of them don't permit it at all. Um, I'm not going to try to break down which does what because that gets into some very, very complex things very quickly. But I will point out that the most straightforward way to do it is literally just to set up horizontal pod autoscaling. And pretty much all the Ingress controllers can tolerate that at least. Um, but another one that gets to be kind of fascinating is you can also consider looking at the Ingress controller. You can change that out. You can look at changing out its deployments for daemon sets and then look at horizontally scaling the nodes rather than horizontally scaling just the Ingress controller. And
Hmm.
if you view things that way, that can have the interesting benefit that you're scaling the available compute resource with your traffic as well, rather than trying to scale a piece of infrastructure without also addressing maximum compute resource. Does that make any sense?
Yeah, I think it
Yeah,
does.
cool.
Cool.
So yeah, in pretty much all of those cases, I should point out that that's utterly independent of what service mesh you want to use because the, how shall I phrase this one? Basically, the mesh control plane, the resource usage from the mesh's control plane, the part that's managing proxies and routing and all that, that tends to scale with the number of workloads you have, the number of endpoints, the number of services, that sort of thing. So as you go and scale out the stuff that's handling the workloads, like, you know, if you have a particular workload that is taking a lot of traffic and it needs to add pods, then that would tend to make your service mesh consume a little bit more resource, but it's just not that big a deal in
Hmm.
practice. The meshes that provide the so-called sidecarless things like to say that they are immune to additional resource or to much additional resource as you add pods because they go, oh, yeah, we don't have a sidecar per pod. But they still have to end up processing the additional traffic somewhere. So they do end up using about the same amount of CPU. And again, if you're talking about memory, then they tend to be using Envoy node proxies. And so they tend to already be consuming a lot more memory. Cue all the people from Cilium and Istio jumping up and down in the chat saying, you're misrepresenting us.
Hmm.
And I don't think I don't think I'm dramatically misrepresenting, but if I am, I apologize.
Yeah, we're all friends here.
Yeah. Well, I mean, in all seriousness, I work with people from Cilium
Yeah,
and Istio with Gamma like constantly. So I really do want to do an accurate job of saying things that are true about their meshes as well. So
yeah.
I believe that I am correct in what I just said. It is possible that I am wrong. And so hopefully not.
But there's social media for settling that out.
Yeah, they'll
Right.
ping me and go, dude,
Yeah, can't believe you're talking about this. Yeah. Well, thank you once again, Flynn, for, joining us. I'm loading
Oh,
up.
absolutely. Thanks for having me. Thanks for bailing out my broken local cluster.
You know, it's almost like that's what we do at Civo. We we provide clusters quick, fast, and,
Shocking.
and easy. Yeah. So it's almost like it was planned. And yeah, hopefully anybody watching can see I've pulled up the Civo Navigate slide once again. We are doing it in just a couple of weeks, February 20th and 21st in Austin, and there will be um, great talks. The keynote is by Solomon Hykes, lately of Dagger fame and obviously previously of Docker. And are any of the buoyant people going to be there? Do you know, Flynn?
I don't know.
Yeah,
We have at least one person in
the area.
Austin all the
Yeah,
time. So, but I don't know. I should check on that. I've heard
yeah,
good things about Navigate from our people who have been there
yeah.
at
Navigate
previous
is
Navigates.
so yeah. I mean, this is going to be the third one, so third
Yeah.
one's the charm. So anybody in the area, definitely check it out. There is a 50% off code on the screen there that is valid, I believe. Well, up until the event, I would believe, but it's specifically for viewers of this webinar. So,
So
um,
use it quickly before people run out or it
yeah,
expires and we don't know about it.
yeah, exactly. And
I
yes,
should
I've
also
just
point
heard.
out
Yeah,
I should also point out for anyone who was watching the debacle with the local cluster, we did not, in fact, plan that. That
yeah,
was an actual live demo failure, and we really did pivot to using a Civo cluster as quickly as you saw during the demo, which
yeah.
should tell you how easy it is.
And
Um,
obviously, I mean, you'd done it before, so you had your script ready to go
yeah, but
to
the
kick
script
one up.
is
But
the the script is not doing anything special. It's literally it is only a wrapper around the Civo CLI because I deal with too many CLIs to remember all of the
all of their
particular
unique
things.
syntaxes.
So
Yeah,
yeah, so it would have been just as quick if I'd used the Civo CLI directly, except I would have had to go fire up a web page to find out, wait, how do I run this again?
yeah.
Yeah,
So I've just heard from Mark, Civo CEO, that in fact William will be speaking. William from Buoyant will be speaking.
flamboyant.
So,
Yes, excellent,
so
even better.
yeah,
William
exactly. So
is
not just attending, but also
yeah,
speaking.
William is that's William Morgan. He's our CEO. He's a good guy who will, I'm sure, stand up on stage and deliver a delightfully cynical, curmudgeonly speech about something. And you should all attend because it'll be a good time.
Yeah. With that, I believe that is our time. Thank you, Flynn, for being a good sport and you know hanging
Thanks
out,
for having
and
me. Yeah.
also thanks to everybody in the chat for spotting things like, oh, the IP has changed
Yeah.
and things like that.
Really
So
appreciate that. That was very helpful.
yeah, I think both of
Um,
us missed it.
yeah, yeah. There's also, I mean, thanks for having me. First off, there's we could go a lot deeper on a lot of these topics. Some of
We'll
these
have
we
to have you
have
back.
gone. Yeah, we can do that again. If you check out the Buoyant SMA link, then you'll find places where we have gone deeper into some of these. At KubeCon in Paris, Mike Morris of Microsoft these days, actually. He and I work together on Gamma, and so one of the things we're going to be doing there is doing a workshop on what the Gateway API can actually accomplish these days and what it cannot, which we will be doing with Linkerd and with Istio and with Gateway API. And I don't know, Kai, I might have to talk to y'all about whether we can spin up a bunch of Civo clusters for that workshop rather than
Uh,
trying to do it locally.
Message me. We'll sort it out.
Yeah, awesome.
Cool. Well, thanks
Much
everybody for tuning
appreciated.
in,
Great to be
and
here.
yeah, and yeah, we will be doing more of these webinars in the future. So be on the
Sounds
lookout
good.
for more of these Civo webinars. And yeah, thank you so much for everybody for tuning in. And yeah, I
Thank you.
guess that's going to
Off we
be it.
go.
All right, bye.